Moving on to geometric series. Well, it turns out that both the doctor and the patient live forever, and so we are interested in S infinity, the limit as n goes to infinity of Sn, if you like, the infinite sum. This is the limit of the geometric sum sequence, and this brings us to geometric series. So suppose that R is between -1 and 1, so this is the convergent case, and we have the geometric sequence, so an plus 1 is equal to R times an. Then S infinity, well, that's the limit as n goes to infinity of Sn, so it is equal to the limit of the first term minus the next term all over 1 minus the multiplier, i.e. the limit of a0 minus a0 times r to the n plus 1 all over 1 minus r. And then by limit laws, we know that this is equal to a0 minus a0 times the limit of r to the n plus 1. And then that's all over 1 minus r. And we know that since r has magnitude less than 1, this limit of r to the n plus 1 goes to 0. And we're left with a0 over 1 minus r. And so this is a formula for the infinite sum, or the limit of the geometric sum. Let's take a simple example. Suppose c is 100, and that would also be a0, and r is equal to 1/3. Then the infinite sum, just applying this formula, is a0 over 1 minus r, so that's a0 divided by 2/3, which is 150. And this could be thought of as the steady state concentration of the drug in the patient right after a dose, in the case where r is 1/3. The other case, where r has magnitude greater than or equal to 1, then this infinite sum diverges. So let's leave off with first order linear recursive equations. Well, apparently the patient already had concentration A of the drug, which had been administered by a different, recently deceased doctor. The drug concentration in the patient now satisfies the total concentration after n days, Sn, is equal to R times the total concentration after n minus 1 days, Sn minus 1, plus C, the new dosage. But it started not at C, but rather at S0 is equal to A, what was existing in the patient, plus C, what was added on day 0. So we can find that Sn is equal to R times Sn minus 1 plus C. A second application of that equation at n minus 1 gives to R times Sn minus 2 plus C. And we could substitute that into the first application to get Sn is equal to R squared times Sn minus 2 plus Rc plus C. And continuing in this process, we find that Sn is equal to R to the n times S0 plus R to the n minus 1 C plus R squared C plus RC plus C. However, S0 is equal to A plus C. So if we separate that out, we get R to the n A plus R to the n C plus R to the n minus 1 C plus R squared C plus RC plus C. Now all but the first term constitutes the geometric sum. So we know that it's the first term, which is C, minus the next term, which is C times R to the n plus 1, all over 1 minus multiplier R. And this gives us now the recursive equation solution. Sn is equal to R times Sn minus 1 plus C, starting at S0 equals A plus C, has the solution. Sn equals R to the n A plus C minus C times R to the n plus 1 all over 1 minus R. And moreover, if the magnitude of R is less than 1, then the limit of these Sn's exists, and it is S infinity is equal to C over 1 minus R. Let's close with an example. So suppose we had Sn is equal to 2/3 times Sn minus 1 plus 1, subject to S0 is equal to 3. Well, we recognize the different pieces. First off, the multiplier multiplies Sn minus 1, so it's clearly 2/3. Secondly, C is added at the end to Sn, so it's clearly 1. Finally, S0 is equal to A plus C, and so since we know already C is 1 and S0 is 3, A is equal to 2. We can now just write down from the formula the solution to this linear recursive equation. Sn is equal to 2/3 to the n times 2 plus 1 minus 2/3 to the n plus 1 all over 1 minus 2/3. This simplifies slightly to 2 times 2/3 to the n plus 3 minus 3 times 2/3 to the n plus 1. Finally, since the magnitude of r is less than 1, we can take the limits as n goes to infinity and find S infinity is equal to 3. Take-home messages. First, a geometric sequence could be written as an plus 1 is equal to a multiplier r times an. Second, a geometric sequence converges provided that r is greater than minus 1 and less than or equal to 1. In the case r is equal to 1, the geometric sequence is constant and the limit is that constant c. The geometric sum is the sum of the first n plus 1 terms, a0 up to an, of the geometric sequence. This sum Sn could be written as the first term minus the next term over 1 minus the multiplier, when this multiplier r is not equal to 1. The geometric series is the limit of the geometric sum, i.e. the infinite sum, and it has the form a0 over 1 minus r, provided that r has magnitude strictly less than 1. Finally, the first order linear recursive equation has the form Sn is equal to r times Sn minus 1 plus c, starting at some point S0. When S0 is divided into a plus c, Sn has the solution r to the n a plus c times 1 minus r to the n plus 1 over 1 minus r.